Okay, welcome back. We're going to be starting our second unit, which is actually the last half of chapter 1. We're going to start this off talking about complex numbers. Okay, we always get the question, why complex numbers? And sometimes you may have heard these referred to as imaginary numbers, which are a part of complex numbers. And electronics is actually one place that complex numbers are primarily used. So we're not going to get into the details of that, but just know that there are real places where complex numbers are used. Okay, so as far as mathematically, why do we need complex numbers? If we start and we try to look at a problem like this x squared plus 4 equals 0, then what we would see is that when we take the 4 to the other side, we end up trying to take the square root of a negative number. So we would have x squared plus 4 equals 0, so x squared would be negative 4. We'll take the square root and we end up with a problem here when we try to do this because we can't take the square root of a negative number and have a real solution. So we had said before that we would have no real solution, but some of these problems we actually need to go ahead and solve. And in order to do that, we have to have this complex number system to get an answer with that. So anytime we're ending up with taking the square root or any even root of a negative number, we're going to need to have the complex numbers as our as part of our solution set. Okay, so with the complex numbers, we start out by defining I as the square root of negative 1. So basically the imaginary part of complex numbers are defined using this I, and so I is the square root of negative 1. If we were to square both sides here, we would see that I squared is equal to negative 1, and that's a substitution that you're going to be making quite often. One thing I want you to remember is that we're never going to leave I to a power higher than just the first power in our final answer. So if we had an I to the second, an I to the third, an I to the fourth, then we're going to need to do something to get rid of those. And so the just a single I is all that you can have left in your answer. You can't have I to any power. Okay, so a complex number is going to be in the form a plus bi. So be careful on your WebAssign directions because a lot of the answers are going to ask for it in this form, a plus bi. A is the real part of this complex number and B is the imaginary part of the complex number. So WebAssign specifically wants it as the real part and then the imaginary part when you start doing that. Okay, so we've already talked about that. If we look at the different parts here, 3 would be the real part and 4 would be the imaginary part. 1/2 would be the real part, negative 2/3 would be the imaginary part. Here, we don't have a real part, so our real part's actually 0. So 0 would be the real part and 6 would be the imaginary part. And then any real number is actually also a complex number because we could write it as negative 7 plus 0i. So 0 is going to represent the imaginary part and negative 7 would be the real part. So, I think it's pretty clear what the real and imaginary parts are here. But when you get down to just an imaginary part or just a real part, those can also be put in the form a plus bi as well if you just make the missing part be 0. Okay, so we want to be able to simplify complex numbers, and these are actually pretty easy. It's very much like working with a variable. If you have something where you're going to add these together, you just want to combine like terms. So if I'm going to combine like terms, that means I'm going to add the 3 and the 4 together, and I'm going to get 7. And then if I add the 7i and negative 2i, I'm going to get 3i. And this is in the form of a plus bi, where my a is 7 and my b is 3. Here, if I'm going to subtract, I would say go ahead and distribute that subtraction sign through, just like if it had variables in it. So it's going to give me a negative 4 and a positive 2i. Then I can combine like terms. So 3 minus 4 would be negative 1. 5i plus 2i is going to give me 7i. And then here I'm multiplying. So when I multiply, I'm going to FOIL. So 3 times 4 is going to be 12. Outer would be negative 6i. Inner is going to be 20i. And then the last is going to be negative 10i I. Okay, so we can combine these two together and we'll get 14I. And in the place of this I squared, we want to replace that with -1. If you remember, I said we can never leave our final answer having an I to any power other than just the first power. So this has to be gotten rid of. And if you also remember, we defined it and said I squared would be equal to -1. So anytime you see an I squared, you need to replace that with -1. So here we'll have 12 plus 14I plus 10. So we'll have 22 plus 14I for our answer. Okay, if you have these i's that are raised to different powers, there's a process that I want you to go through. And that process is I want you to rewrite it as I squared to some power. So the way we'll figure that out is we're going to basically think about if 23 is divided by 2, 2 goes into 23 11 times. Okay, so that gives us 22. Subtract here, and we've got 1 left over. So what I'm basically saying here is if I have I to the second, then I'm going to have 11 of those. So I'm going to use this number 11. And then I've got 1 that's left over. So I'm going to have I to the first. So what I've done, if you think back to our properties of exponents, this is 2 times 11 would be 22 plus 1 would be 23. So I'm really just rewriting this 23 in a different format, but I want to make sure I'm doing an I squared here, and that's important because we know what I squared is. We know I squared is -1, so we're going to replace this with -1. Okay, we also talked back on probably the first day of class about if we have a negative raised to an odd power, then that's going to stay a negative. So this is going to be -I as our answer. Because we can leave our answer as I to the first power, we just can't have it any higher powers. And I'm sure at this point that's a little fuzzy, so we've got several examples here that we're going to go through to hopefully clarify this. So again, we're going to start out with I squared, and we need to figure out what power that's going to be. So if I take 34, and divide that by 2, 2 goes into 34 17 times, and there's no remainder there. So this would be I to the 17th, and I'm not going to have anything out here because it went in evenly. So when I go to simplify this, this would be -1 to the 17th power, just replacing I squared with -1. A negative to an odd power is going to stay a negative, so my answer would be -1. See, here it was -I because I had an I outside the parenthesis. I don't have anything outside the parenthesis, so it's just going to be the -1. Okay, on I to the 24th, again, we'll start out with I squared. And if we think about 24, we'll divide 2 into it, and it'll go 12 times. So this would be I squared to the 12th power. So that's going to be -1 to the 12th. A negative to an even power is going to be positive. So my answer is +1. Okay, here if I take 19 and divide it by 2, 2 goes into 19 9 times with 1 left over. So I'm going to have 9. So 9 times 2 is 18. And then I've got 1 as a leftover here. So this one's going to be -1 to the 9th times I. So it's going to be -I. So it's actually the same as A here. Okay, I have a few of these for you to practice, so I would encourage you to pause the video at this point, try these 4 problems, and then check your answers. Okay, these are the answers that you should have gotten. On the first one, we were simply combining like terms together. On the second one, you've got the negative, so distribute that negative through the second parenthesis and then combine like terms together. You do have some fractions here, so -1/2 minus -3/2 gives me -4/2, and that reduces to be just a 2. On this one, you're multiplying, so we would FOIL this out, and the main thing there is to remember that you've got this I squared that you need to replace with the -1 and simplify that. And then we have the I to the 25th, so we'll divide 2 into 25, it goes 12 times with 1 left over. So you're going to end up with, in this case, a positive I for your answer, because the negative to an even power is going to become a positive. Okay, so we looked at adding, subtracting, and multiplying complex numbers. Now we want to look at dividing these. If you recall, I is equal to the square root of -1. So basically we have a radical here, and in a couple of sections ago we talked about rationalizing our denominators. So essentially that's what we're going to be using here. We're going to use the conjugate again, just like we did when we rationalized denominators. So if I look at this, and I need the conjugate of the denominator, then that's going to be the same terms but with an opposite sign. And I'll do the same thing in the numerator as well. Remember, we're going to multiply the numerator and the denominator by the same thing. So now we're ready to FOIL these out. So first, outer, inner, and then last. And then I'm going to do the same thing here, except the purpose of the conjugate is that the inner and the outer terms cancel each other. So I'm going to do first, inner and outer cancel, and then I'm left with minus 4i squared. I'll simplify what I can. So I have 3 plus 11i, and this is I squared is equal to -1. So in the place of I squared, I'll put -1. So I'm going to get -10 for this part. And in the place of this I squared, I'm also going to put -1. So I'm going to end up with a plus 4. Here I have -7, combining the 3 and the -10 together. And then I have 5 for the denominator. So I have -7 fifths plus 11 fifths I. If I come down to this example here, I have to remember that 4i is actually 0 plus 4i. So the conjugate of 0 plus 4i is going to be 0 minus 4i. And that's what I need to multiply this by, 0 minus 4i. And to simplify it, I'm actually going to not put the 0 there. So I'm just going to have -4i is what I'm multiplying by. So I'll distribute this to each one of our terms. I'll have -28i and then -12i squared. The denominator would be -16i squared. I'll simplify. This is going to be equal to -1. So -12 times -1 will be +12. Again, here's another I squared, so that'll be a -1. So I end up with a +16. Okay, we've got a couple things to do to finish this up. One, we need to simplify our fractions, and two, we need to put it in a plus bi form. So if I reduce this, I can see that 4 goes into 12 3 times, and 4 goes into 16 4 times. Okay, so that's my A term, and now my bi term, I'm going to reduce here. Both of these are also divisible by 4, so I'm going to have a, and I'm going to change this to a minus here. So I'm going to have a minus 7. 4 goes into 28 7 times. 4 goes into 16 4 times. And so this is my answer in A plus BI form. Okay, I have 2 problems here for you to pause the video and try. Be sure that you're doing that when I give you the opportunity to, and then you can check your answers on the next slide. Okay, these are the answers that you should have gotten. The conjugate on this one will be 1 plus 2i. Again, opposite signs of what you start with in the denominator. Multiply the numerator and the denominator by the same thing. And FOIL that out, replace your I squareds with -1s, and you should get this as your answer. On this one, the conjugate of 3i would be -3i, and you'd multiply the numerator and denominator by that and replace the I squareds, and you get 2 minus 4 thirds I. Okay, we need to talk about some problems that involve simplifying these square roots of negative numbers. We already mentioned that the square root of negative 1 is I, but sometimes you're going to have other things besides just negative 1. So if I have the square root of negative 16, we want to think about that as breaking it up into the square root of negative 1 and the square root of negative 16, or sorry, positive 16. So the square root of negative 1 is I, square root of 16 is 4. Typically we write the 4 first, so it'd be 4I. On this one, if I have this negative underneath the radical, basically you saw by this process here that what it does is it comes out in front, and when it comes out in front, it comes out as an I. So it's going to be I on the square root of 3. So some are perfect squares, and you can simplify those. Others you can't, and you just have to leave it like that. This one we're multiplying, so if you remember, you multiply outside to outside and inside to inside. So I times I would be I squared, and then 5 times 5 would be 25. I squared is negative 1, and 20 square root of 25 is 5, so my answer is going to be negative 5. Here we would have I times I would be I squared, and this would be the square root of 15. So we're going to have negative 1, and the square root of 15 can't be simplified, so we're going to end up with negative square root of 15. Here's a couple for you to practice with. And these are the answers that you should have gotten. Okay, we have to be very careful when we're doing problems that involve square roots of negative numbers. So I want to show you kind of the reason for that. If we look at this problem here, the correct way to do this problem would be to take the negative out as an I on each of these before we multiply. So it's very important that you do this step first. Otherwise, you're not going to get the right answer, because if you think about it, we've always said you multiply inside to inside. So if I multiply inside to inside, I'm going to get negative 2 times negative 3 would give me a positive 6. But that is not the way that we want to do this problem, because that does not give us the correct answer. The correct answer on this problem will be negative square root of 6. You're going to lose this negative if you actually multiply those straight to begin with. You've got to take those negatives out in front before you start multiplying. Okay, so here's a couple that we're going to go through and look at. This one, we need to FOIL this out, but if we jump right in and start trying to FOIL it out, we're actually going to miss the problem. The first thing that we want to do is, and just ignore this here, is we want to simplify all of this before we do our multiplying. So if I'm looking at the square root of 12, this goes back to simplifying radicals. So this is going to be 2 on the square root of 3. This one is going to be, we've got the negative, so it's going to be I on the square root of 3. We'll keep the 3. And then this is going to be, we've got a negative under the radical, so this will be 2I. Now, once we've done that, we can actually FOIL this out. So if I'm going to multiply first times first, I'm going to have 6 on the square root of 3. Outer is going to give me 4I on the square root of 3. So I've got 2 times 2 gives me 4. I've got an I, and I've got a square root of 3. Inner is going to be 3I on the square root of 3. And then last is going to be negative 2I squared on the square root of 3. Okay, so just really keep track of everything, and I think you'll be fine with it. So we need to figure out what we can combine together. We've got 6 on the square root of 3. These are actually alike because they both have an I and a square root of 3. So I have 4 of them and I have 3 of them, so that leaves me with just 1. And then on this one, we've got a negative 2. This will replace with a negative 1. So negative 2 times negative 1 gives me a positive, and that's going to be 2 on the square root of 3. Sorry about all the lines. And we've got one more set that we can combine together. We've got the 6 on the square root of 3 and the 2 on the square root of 3 will give me 8 on the square root of 3 plus I on the square root of 3. And so this would be my A, and then this is going to be my B. Okay, here's one to practice with. If you want to practice, that's fine. If you want to listen to me go through it, that's fine as well. So here we need to simplify first. So this is going to be 3 minus I on the square root of 5. And then this one's going to be 1 plus I. From here, we're ready to FOIL. So 3 times 1 is 3. Outer would be 3I. Inner is going to be negative I on the square root of 5. And then last will be negative I squared on the square root of 5. So 3 plus 3I minus I on the square root of 5. And then here we're going to have, this is going to be a negative 1. So negative times a negative gives me a positive square root of 5. Okay, so I need to group my terms that do not have an I together. So the 3 and the square root of 5, that's all going to represent my A. And then over on this part, I'm going to group this and this together. I'm actually going to factor out an I. So I'm going to have 3 minus the square root of 5. And so this part is going to be my B. So it's a little bit more complicated than the one we just did as far as putting it in A plus BI form. So when you're putting it in A plus BI form, sometimes you have to factor that I out so that you can actually find the B. Okay, so all of this work with complex numbers actually takes us to really our main purpose for looking at complex numbers here, and that is to be able to solve a quadratic equation using the complex number system. So if we look at this first one here, we've got x squared plus 9 equals 0, and we'll need to move the 9 to the other side to solve this. We're going to take the square root of both sides, and we get the square root of negative 9 is going to be 3I. But when we're solving it in the context of a problem like this, it's going to be plus or minus 3I for our answer. So if you have to be the one to take the square root in order to get the x by itself, then you're going to get the plus and minus as part of your answer. If you just have a problem that looks like the square root of negative 9, then that's going to be 3I. Okay, if we look at this example here, we're going to use the quadratic formula for this one. So we'll have negative b plus or minus the square root. I found that if you go ahead and do the b squared, I think it's actually alleviates some of the issues. So this is my b. If I square that, it's going to be 16 minus 4 times a times c. And then all that's going to be over 2 times a. So I'll have negative 4 plus or minus the square root. This will be 16 minus 20, so negative 4 all over 2. We know that the square root of negative 4 is 2I. And if we break this up, we'll have negative 4 over 2 and 2I over 2. So we'll have negative 2 plus or minus I as our answer. Okay, here's a couple for you to practice with. And here are the answers to these. One thing I wanted to point out is when you get over here and start breaking these up, this one's pretty straightforward. This one you have a negative 8 underneath, so you need to simplify that just like we would any radical. You'll take the negative out in front, and if you do your prime factorization for 8, you'll see that it's 2 to the third. So we have enough 2's so that we'll take 1 out and leave 1 inside. And then when you go to break this up, you're going to put it in the A and the BI form and simplify your fraction. So the 2/6 reduces to 1/3. And again, the 2/6 reduces to 1/3. And that takes us to the end of our lecture on complex numbers. Again, if you have any questions, I've gone over the resources before. Please reach out and get help if you're struggling with this. Thank you and have a good day.